So let's see.
Oh, I'm here.
Ah, you're there. Great. I'm excited. So, are you ready? Could you talk right now?
You just wait a second.
Sure.
Uh, Let me share my screen. Okay.
Yeah, we see that. Thank you very much. Go ahead.
Uh, what I call implicit compilation is a new feature of zeptoforth where you can do things like this. Wait a second. And this, you can't see it here, obviously, but this is toggling the LED. But if you notice something close about it, I didn't define a word for this to execute within. Rather, this is being executed outside of any word definition. Well, how it works is that if the zeptoforth interpreter sees a word such as begin or, okay, let's say -1 true if who else bar that, or if is another one, it'll immediately start compiling an anonymous word. And then once it reaches a matching syntax, let's say in this case, then it immediately executes the word, and then it rolls back the code that it compiled. And you can see that it doesn't use any more RAM. But first, you can see the main text dictionary free. And then this time I'll do false. And then I'll do unused again. It didn't actually use any RAM in a persistent fashion, even though it is defining a word when it's executing it. And you can and this isn't limited to a single line of input. For example, I can do, instead of the single line execution I specified earlier, actually I'm gonna end this one because I got to implement something. Okay. I do 0 begin, e not while do. It's only when I hit repeat that it starts doing this. And when I hit enter, it stops. And you can also do it with things like case, for instance. Let's say we have 0 case, 0 if who, no, oh, not yet. Who, end of, one of bar end of two of Baz end of the end case, and then it's only when I enter end case does it call, does it execute that. And this whole thing, to me at least, solves a lot of a seeming gap in a lot of forts where uh, you can't do conditionals or loops or stuff like that outside of the word definition, which from my having used, let's say, Python in the past, Python doesn't have such a limitation. And there's no good reason why Forth shouldn't have such an limitation either. Of course, there's certain things you cannot do with this. Like, this might not crash in this example, but it's not something you want to do. And what it's doing with it here with end here is that that is equivalent to true until, except for it doesn't actually compile any conditional branch. It's just to match begin to allow a scope to be defined and nothing more. But this, for instance, will result in undefined behavior. Like, let's say I do this again, and what happened here is that I overwrote the code for the previous lambda that I defined. Because after each time implicit compilation is complete, it rolls back the here pointer in RAM. But then I overrode it again by defining new code. And that's why it only executes the printing bar rather than both foo and bar. Which, of course, that's a catch that that's a catch. So you don't want any like lambdas or like to last outside the scope of the implicit compilation. Because it'll be the pure pointer will be rolled back and then it'll be later overwritten. I think it's going to reboot here. And that's pretty much what implicit compilation is. Once you actually think about it, it's not all that exciting, but at the same time, it's as I mentioned, it's filling a gap in your typical form. So I think I'm done with my presentation. If anyone has any questions.
Yeah, thank you very much. And my question would be, can inside the control structure, if you have loops, can you also compile things or add to the dictionary so that you can maybe
No,
initialize a
you
data
cannot
structure?
add to the uh well, you can't add to the dictionary because what happens is that it saves the here pointer and then it allows the user to compile whatever they want after that.
Mm-hmm.
And then once it's done, it rolls back the here pointer to its original position.
Mm-hmm.
So if you define something like a word internally, that word, the here pointer will be rolled back. But if you change the latest pointer, which is pointing to the most recent word, that is likely to cause problems because uh, implicit compilation assumes that it can just roll back anything that the user had compiled after it.
Mm-hmm. Mm-hmm.
Hence
Yeah,
the fact that the unused, when you call it unused before and afterwards, the dictionary size left for RAM is exactly the same.
I see. I see. Yeah. Um, I played around with this concept well, many, many years ago. And what I did is I moved the temporary definition that you create to some other location. So, and then reset the dictionary already. And then when you execute, it could actually add programmatically wise to the dictionary, like initialize the data structure. Inside a loop, you could do 0, for example, to allocate memory. And that was quite helpful.
Yeah, the problem with
But it's,
doing relocating code under zeptoforth is that zeptoforth is a native code compiler, and when it compiles to native code, there is the BL instruction,
mm,
which is a branch to it means branch and link, but it's pretty much branch to subroutine, and it takes an argument that is a uh, distance, a relative distance from
mhm.
the BL instruction. So if you moved your code, you have to go through all the code and update all of the offsets for the BL
Sure,
instruction.
sure, sure, sure. Yeah, the
I
code
see
must be
Atlee wants
relocated.
to talk.
Mhm. I see. So how do you do the switching to compilation mode? Do you have some stacks or some counters or?
Uh, how I do it is that I make certain conditional and looping words smart. That is, they'll be executed both in compilation mode and interpretation mode.
Mhm.
And what all the conditioning and looping routines do is they use something called, I call it the syntax stack, where let's say if you do if, it'll push an if syntax onto the syntax stack, and all your subsequent looping and conditional words will either add to or remove from that stack. And then finally, once it encounters a then it'll see, hey, I'm this if on this syntax stack is the only thing left. So, and because I'm not within a word definition, because a word definition with a colon pushes a syntax onto the syntax stack. If I'm at an if and there's no colon syntax next thing on the syntax stack, say, hey, it's now time to go and execute this code that's been compiled and then roll everything back.
Mhm. Mhm. That's great. What happens if you have some errors in the code that you type that you compiled?
If there's an error, it will automatically roll back the changes made.
Yeah, I
Like
see.
for instance, let's do begin. Okay, let's do unused. Just to show that would do begin foobar again. And foobar doesn't exist right now. So
Mhm.
we get this error, unable to parse foobar.
Mhm.
and we do unuse. And as you can see, it rolled it back because the dictionary free pointer is exactly the same. Or let's do something more detailed, just in case. Begin, foobar, foobar. Okay. And let's do this again. And again, even though it compiled this before the word that it actually got caught on, the main task dictionary free is exactly the same afterwards, showing that it had rolled it back.
I see. Yeah, thank you. Atle, you had a question as well.
Yeah, no, it looks like you have a scope. So every time you add a word that increases the scope, you like push the indentation level in, and then you can push it in, and then it comes back out. That's what I was picturing in my head when I saw what you did. But I was wondering, so you start off a loop, and then you continue, you write something inside the loop, and then you finish the loop. But then what happens when you come back to the outer scope, the outermost scope? Are you starting a new nameless word, or what's happening to the old code? Does it get overwritten, or what happens?
Atlee, could you turn up the gain on your microphone, because I was having trouble hearing you?
Hold on. Mm, is it better now?
Yep.
It's a bit better.
Yeah, it's better. Hold on. Just
Mhm.
a moment. I'm having microphone troubles all the time. No, I was. Can you hear me well now?
A bit better.
I can increase it further.
Sure.
How about now?
Mhm.
It's
That's
probably
all.
fine.
That's all the way up. No, I was thinking of scopes when you started off this loop, and then you wrote something inside the loop, and then you finished the loop. And then I pictured like an indentation level, like in C, you increase indentation when you have a new scope, and then I could see a scope counter going up and down. I don't know if that's how you did it. It sounded different when you explained it. But anyway, so you start off this loop, right? And then you end the loop. And then you start something new. What happens to the old code? Is it still there? You can't reach it anymore.
Um, the code that you compile within, let's say, a loop this way, it is not usable after you exit the loop. For instance, uh, here's the example. Begin foobar, and then we're gonna just define a lambda here. And do H8. So that's the address of the lambda. But when we do here, H8, the here pointer is before the lambda that we defined. So subsequent compilation will overwrite this lambda. So basically anything you define in implicit compilation that's within the dictionaries for the main task has to be treated as being transient. It'll all be, it's not valid afterward. Did I get your question right?
Mm-hmm. All right. So are there any further questions to Travis? Doesn't seem to be the case, so thank you very much again. I think this is
Welcome.
inspiring, and it's probably a nice extension to have in many force systems. So yeah, not everyone has a syntax stack, so the implementation will probably be system dependent, but I think it's rather a nice extension to use control structures interactively and do this kind of implicit compilation. Right. So we proceed, I would say, to our next speaker, which is Jos Ven, and he will talk about